Hi, thank you for joining me on this short Mosel training video on linear programming. In today's video, I'm going to demonstrate how you can use Mosel to build an optimization model. To start with, I would like to describe the problem that we are looking at. A manufacturer produces 4 different types of wood boxes. Each product requires a known amount of wood and some hours of machinery at the processing time, and the demand for each product is known for the next 4 periods. So the objective function being maximizing profit, how many of each item should we produce? To model this problem as a mathematical optimization problem, we introduce our first continuous decision variable as the amount that we should produce of product P in period T, and the mathematical model can be written this way. We are trying to maximize the objective, which is the profit, and we need to make sure that we honor the wood capacity and the time cap that we have in each period. Now I would like to go back to the Mosel file. To gain access to the Xpress Optimizer, linear programming optimizer, to gain access to Xpress Optimizer, you would need to add this command here, mmxpress. Once we gain access to that library, we introduce our production variable as an array of products and the number of periods, which is 4 in this case. And the name mpvar stands for mathematical programming variables. Decision variables are unknown. They have no value until the model is run and the optimizer finds values for the decision variables. In optimization problems, decision variables are often just called variables. In computer programs, a variable can be used to refer to many different types of objects, for instance, integers, reals, and other types. But in optimization, here, moving forward, when we use the word variable, we mean decision variable. The objective function is a linear description of the decision variables, and we use the same command, linear constraint, for declaring both objective and constraints if you would like to name your constraint. So now that we have defined our decision variables and the objective, we go to our procedure where I built my model. So the objective function is the sum of all products and all periods, the amount that we produce, times the product profit. And then we have 2 sets of constraints. The wood capacity constraints, where for each period we need to make sure that the amount that we use for production of each product is less than the capacity that we have in that particular period. The second constraint that we have is about honoring the available hours, and for that we need to make sure that the total amount of processing hours that we use within that period is less than the time capacity that we have. And finally, you could maximize the objective or you could minimize the objective with a negative sign. So we could use both maximize or if I wanted to show you, minimize the minus objective. We have both options. Before running my model, which is very simple, I would like to deactivate the procedure data processing because I don't want to change my data. It was just for showing you how you can use programming features within Mosel. And now within the optimization model, I call my procedure. So now if I run my model, you would see the defining arrays, reading input data from Excel file, and now the problem statistics. We have 8 rows, as in 8 constraints. Global statistics, as in if you have any integer variables, which we don't in this case so far. And we have 16 columns, as in 16 variables, which are variables of produce. Then you see we have 16 entries. And these are the values for each entry. If you are interested in learning more about linear programming and classical optimization problems, please go to your Xpress installations, and under examples and Mosel, you can find lots of examples that might be interesting to you.